Welcome everyone to our third webinar in the series of Get the Most Out of Your Patch as part of the 2020 Sustainable Garden Awards. I'm Naomi Dulett from the City of Norwood, Payneham and St Peters, and I am the Sustainability Officer here. Before we begin, I'd want to start with an acknowledgement to the traditional owners of the land that we're presenting on today, the Kaurna people. I'd like to pay our respects to their elders past, present and emerging. Today, we're speaking with Professor Tim Cavagnaro from the University of Adelaide about healthy soils. If you have any questions today, you are able to ask them through the live chat function on YouTube. And if you ask any questions prior to the presentation, they will be answered at the end as well. So now I'm going to hand over to you, Tim.
Great, thank you, Naomi. I'll just share my screen. So hopefully you can now see my presentation. And sorry. Okay, excellent. Look, thank you for that introduction. It's a great pleasure to be here speaking today to people about soils and healthy soils and all these really important things that I think we really care about. I'd also like to thank Norwood, Payneham, St Peters for the opportunity to present this seminar. It's a really great program that you have running, and I'm really pleased to be a part of that. So what I'll do is I'm put together a couple of slides and I'll talk through those, and then hopefully there'll be some questions at the end. And as Naomi said, we've received some prior to the seminar as well, so I'll run through those as well. Okay, so what's the dirt on soil? That's really the topic that we're talking about here. And often when we think about soil, the first thing people think is it's dirt. And the first thing I want to say is soil is not dirt. They're two very different things. Dirt is something that's sort of inert and not alive, and we don't really care about it, and it's a bit messy and it gets in the way. Where soil is this tremendously valuable and precious resource that's alive and living, and it's something that we very much need to protect and look after. So the first thing I really want to do is talk about what is soil and break soil down into its basic components. So on the left-hand side of the screen here, we've got a fairly familiar image of a soil core, and you can see that mineral soil that makes up that soil core. If we were to have a look at that a little bit closer, it's made up of particles of different sizes, okay? And so as soil scientists, we break those particles down into different size classes. We've got the sand, the silt, and the clay. And so the sand are the particles that range from 0.05 millimeters up to 2 millimeters in diameter. Okay, it's that familiar material that when you hold a handful of soil and you rub it between your fingers, you feel that gritty material. That's the sand that you're feeling. The next size class down is silt, which is 0.05 to 0.002 millimeters. And then the very small particles we have are the particles, and they are less than 0.002 millimeters in diameter, or 2/1000ths of a millimeter. So if you were to take a millimeter and divide it into 1,000 portions, clay particles would be less than 2 of those in diameter. So they're very, very small particles. The way that I try and visualize this is to say that sand is a bit like a big beach ball, silt is a bit like a golf ball, and clay is probably about the size of a 1-cent piece. Okay, so we're dealing with particles that vary quite considerably in their size. And as a consequence, they vary greatly in their surface area as well. And so what I mean by that is if you were to take some coarse sand and measure the surface area in 1 gram of coarse sand, it'd be about 10 centimeters by 10 centimeters squared, about 0.1 square meters in surface area. But if you were to take clay particles and measure the surface area of those in 1 gram, in very fine clays, the surface area would be the same as about 2 tennis courts. Okay, and to me, that's a remarkable fact that if you think about 1 gram of fine clay has the same surface as 2 tennis courts, that's a huge amount of surface area that's in those clay particles in those soils. And so lots of really interesting chemical reactions can happen on those clay particles. And so that's why clay is a really important part of the soil environment. Okay, so we've got our soil. It's made up of the soil particles of different sizes, and they can get stuck together and form what we call aggregates. And so those are the sort of crumbs of soil that you see when you hold a handful of nice, healthy soil. The next thing when we think about soil is that it also contains a lot of empty space. It's actually quite remarkable to discover that if you're standing on soil, about half of the soil that you're standing on is actually empty space. It's the spaces between those particles. And those spaces are full of lots of gases and water and other things moving around as well. So we've got this fairly solid material, but it's actually a very porous material. And so the image on the screen here on the right-hand side, a CT scan, much like you would have at the hospital if you're having a CT scan, you can take a CT scan of soil. And what you can see here of the soil is in grey, and then all of the empty spaces show all these pores that will be filled with gases and water in the soil environment. So much of the soil is actually effectively nothing, right? It's empty space, and lots of things can move through that environment. And of course, one of the most important things that moves through the soil pores is the water. Now, water is really remarkable stuff. And this amazing photograph here shows an ant, and the ant's actually carrying a droplet of water, and it's got another one on its back. And that's really there to illustrate this idea that the surface tension of the water is really, really important. Water wants to stick to things. Water molecules want to stick to one another, and they want to stick to things. And so if you imagine the soil as a series of solid particles with a bunch of pores and little tubes in between them, all these empty spaces, the water moves through those. But the smaller those pore spaces, the more tightly held the water is. And we know that, right? If you take a bucket of sand and you pour some water on top, it disappears, it drains very readily because you've got big spaces between the particles. But if you take very small particles like clay particles, it's actually hard for the water to basically be lost from that soil because it's very tightly held in those small pores in the soil environment. The other thing about water in soil is it does some really strange things as you get down to lower and smaller sizes. So if an ant wants to drink some water, it actually picks up a bubble of water in its arms, and it can consume it that way, as you can see in the photograph here. If you go down to an even smaller scale, again, where we're talking about the size of things like bacteria in the soil, the water actually sticks to the surfaces and it can move up and down and left and right. So it'd be like being in a room with water running up the walls and stuck to the roof. So water behaves in very strange ways in the soil environment, and it's very much dependent upon the size of the particles in the soil, but also the way that those particles are stuck together. And the glue that holds those soil particles together is the organic matter. And so the addition of organic matter to soil is a really important thing for improving the movement and retention of water in your soil. Soil is an incredibly complex material, is the point that I'm trying to make. And I would argue very strongly that soil is the most complex material on the planet, because within this one material, you've got the solid phase, you've got the particles, you've got the gas phase, the gases moving between the particles, and the liquid phase, right? You've got the water in the soil solution moving through the soil. And that environment creates a huge amount of complexity. And if we have a look at some examples of soil profiles, so what this image is showing is that got the surface, and then we've got down through a soil profile, and there's some profiles on the top, and there's some on the bottom as well. And you can see the huge amount of diversity in Australian soils. And this is just a quick subset of soils. We've obviously got a very sandy one here. We've got one here that's very bleached. We've got one that's full of organic matter, the sort of quintessential Australian red soil in the middle here. The point that I'm trying to make is soils are very, very variable. Okay, and there's a huge amount of complexity. And so that complexity brings about challenges in terms of how we manage our soil, okay, because you need to understand the nature of your soil in order to be able to best manage it. But it also creates a fascinating environment. Oh, with all of this complexity, you get a huge amount of diversity in the soil. So soil is a living material. If you take nothing else away from this presentation, it's that soil should be viewed as an ecosystem. Okay, if I was to take a handful of soil from my garden and count all the bacteria that are present in that handful of soil, there would be more bacterial cells than there have ever been people on this planet. Not the current human population, but people ever. There are many, many tens of billions of bacterial cells in a handful of soil. There's also very many tens of meters of fungal hyphae growing through the soil. A nice example, we did some work on tomato farms in California, and organic tomato farms, and we found up to 10 centimeters of roots in the surface soil per gram. Okay, so imagine 1 gram, about the size of a sugar cube, that contained 10 centimeters of roots. It may have contained many tens of meters of fungal hyphae, and it would have contained many tens of billions of bacterial cells. So the soil is this incredibly diverse, rich environment that's full of life. And just to illustrate that point, if we were to take a hectare of soil and measure the biomass, so the weight of all of the microbes in a hectare of soil in the top 10 or so centimetres, there'd be about 250 kilograms of microbes, of bacteria and fungi and other microbes in that hectare. And the way that I kind of visualise that is it's equivalent to about 5 sheep. Okay, so if you look at a farmer's field and it's about a hectare in size, if you've got 5 sheep there, you've got just as much microbial biomass in the soil as well. So you've got this huge amount of microbial biomass, and all of those microbes are doing really important things. They're transforming nutrients, they're building carbon, they're regulating the flow and the cycling of resources in the soil, they're improving the soil structure. So they're a really important part of that environment. So 5 sheep per hectare equivalent microbial biomass. If we look at the worms, and this is a number from a recent study where we're doing some work in the Barossa Valley looking at vineyards, and we found up to 1 ton of earthworms per hectare in those soils. That's the equivalent of about 20 sheep. So again, that's more sheep than you would normally have per hectare on a farm, on a grazing farm in that region. So there is a huge amount of life in the soil. Those worms and all of those microbes are providing all these valuable services that we want to know about. And so building and bolstering and supporting and preserving the life in our soil is, I think, one of the great challenges, because it really is such an important component of the system. Right, so soil. Hopefully by now I've convinced you it's not dirt. It's this very valuable living resource that we have that underpins agriculture, that underpins biodiversity. It helps filter our air and our water. It's the base of our ecosystems. It's this really important thing that we need to preserve. The thing about soil is it takes a really long time to form. Okay, it takes a very long time to make a mineral soil. Formation rates are about 0.1 millimeters per year. Okay, so the way that the soils are formed is through the degradation or the weathering of the parent material, so the rocks, through this process that we call pedogenesis, and that leads to the formation of soils, and that occurs at about 0.1 millimeters per year. To put that in perspective, over the lifetime of the average Australian, that's about 8.21 millimeters formed. Okay, so over an 82-year period, we're getting about 8 millimeters of soil formed. To put that another way, a 1 meter soil profile takes about 10,000 years to form. So it takes a really, really time to form soils. The problem that we've got is they can be lost in moments. We can lose years, decades, hundreds of years of soil in moments. Okay, if your soil is not well protected and well managed, through an erosion event, you can lose millimeters of soil very, very quickly, and that represents substantial amounts of time. So the real challenge that we've got with soil conservation and management is that soil takes a long time to form, it's incredibly valuable, but it's also very delicate, and it can be lost quite rapidly. So we need to work really hard to preserve and manage our soils. And I would argue that that's one of the greatest challenges of our time. If we're going to achieve global food security, we need to double global food production by 2050 if we're to achieve food security. If we're going to address the problem of climate change, there's a lot of carbon that's stored in the soil. If we're going to deal with problems like biodiversity loss, so contamination of waterway with nutrients, that really, all of those issues have soil at the heart of them. And so again, it's really to try and make this case that we need to preserve and look after our soils. I think another point that's really interesting as well is Australia has among the oldest soils in the world. And so they're quite heavily weathered, they're low in nutrients, and they've been here for a very long time. And so they are particularly fragile. Okay, so it's not all doom and gloom. I can answer, I think, around what does soil want? Well, basically the same things that we want. Okay, soils want food, they want water, and they want shelter. And so when I talk about food in the soil, I'm talking about organic matter, right? The leaf litter, the exudates from the root, compost, all of those sources of organic matter that we can add to our soil. That provides food for the organisms that live in the soil, and that's really, really important for them to be able to do their work to help stabilize the soil, to regulate the flow and cycling of nutrients as well. Soils want cover, they want to be protected, they want shelter. And so bare soils are at much greater risk of things like erosion okay, from being blown away or washed away. And so having cover on them, having plants growing on them, having mulch on them is a really good strategy for helping to protect your soils as well. The other thing that soils don't particularly like is being heavily disturbed. And so there's been a massive shift in Australian agriculture from what we call conventional tillage to conservation or no tillage. And so this is where in broadacre farms, rather than cultivating the soil very frequently to control weeds, people are now minimizing the disturbance of their soil. They're not ploughing it up on a very regular basis, because when you come through and plough the soil, you're actually breaking up. Okay, you're breaking up all of those living networks of beneficial fungi in the soil and disturbing and exposing new surfaces to oxidation and processes like that. So minimizing physical disturbance of the soil is also important. I think the key point here is that they also want someone to take care of them. And so I think we have to think about soil as this delicate resource, this very complex resource upon which so many things depend. And so we're really the stewards of our soil. We need to look after our soil, and that's really about how we manage it and how we value it. And so I think if we start to think about the services and the benefits that we receive from soil, it really changes at a society level, it really changes our mindset towards how we view soil. And that's probably one of the most important things that we can do. Okay, so I think that's probably a good point for me to stop with the slides. Again, my name's Tim Cavagnaro. I'm a professor of soil ecology at the University of Adelaide in the School of Agriculture, Food and Wine. I'm on Twitter if you want to follow up with me there as well. More than happy to take questions. I guess the other thing I'd say at this point is we did receive a few questions, and so what I might do is just run through those now. And if there's any others, if you could pop them up in the chat, that would be great, and I'm more than happy to answer them. So the first question that someone sent through was, what is the most useful thing one can do to keep soil healthy? Well, I think I probably covered that in the final slide there, that it's really about protecting our soil, providing it with the resources that it needs. So adding organic matter to the soil is a really important thing that you can do to help keep it fed and alive and healthy. I think the other thing that we can do is whenever you do something to your soil, consider the impacts that that might have on that ecosystem. And I think if you get into that mindset of thinking about your soil as an ecosystem, that's probably the best thing you can do to keep your soil healthy. Okay, this next question I really appreciated. Someone said, what can I add to my soil as an organic fertilizer that won't get eaten by my dogs? For example, they spend the next few weeks working, eating various organic amendments that they put in the veggie patch. I very much understand this problem. I used to have 2 golden retrievers, and they would go in and eat absolutely any organic amendment that I added to the soil, which was both frustrating from a gardening perspective, but it also wasn't particularly good for them. So what I would say here, the thing that I found most effective was adding liquid-based products. When you add a solid material, if the dogs like the smell of it, they can go in, they can find it, and they can eat it. But if it's a solution, it leaches into the soil, and that's much harder for them to consume. They might go in sniffing around and try and dig it up, but that was what I found was most effective with 2 dogs that were very keen on eating anything. Someone has asked here, what's the best soil preparation method for a veggie patch? There's sort of 2 points here. One is whether or not you're using the soil that you already have, or whether you're working with raised beds. So if you're working with a raised bed and you're importing a vegetable soil that's had lots of compost and fertilizer and nutrients added to it, that's probably a really good starting point. I think if you're working with the soil that you already have, my key advice here would be to add organic matter. So working in things like compost, you might add in some plant material, but really adding that material into your soil is probably the key thing for veggie patch preparation from the perspective of feeding the life in the soil. The next question was around natives to plant in clay soils and how best to prepare the soil. So my advice here with natives is to really look at what would have grown in your local area. What would be naturally growing in your local area? And around Adelaide and, in the Lord Payneham St Peters area, there are a number of patches of remnant vegetation that you can go and visit, and you can have a look at what's growing in those patches of vegetation. And that should give you a pretty good list of the plants that will grow in your local environment. Okay. The other thing that you might consider is you can get really good advice from the nursery up at Belair National Park as well. So they can often help if you talk to them about where you are in Adelaide and about your local soil conditions. They can usually give you some really good advice about what might grow well in your local area. You know, clay, so lime is something that you can, or gypsum rather, is something that you can add to the soil to help deal with clay as well. The thing with gypsum is that it's good to lay it down before you put something on top of it, and frequent applications of smaller amounts are probably better than a massive application all at once. Right, someone has asked, can you easily reduce the soil pH level? That's a really interesting question. So yeah, if your pH is alkaline, so you've got a pH above 7, there are various things you can do. One is aluminium sulfate, I believe, can do that, or from an organic addition, peat moss is something that people recommend as well. Probably the best advice is to measure your pH and go to your local garden centre and say, this is the pH of my soil, what do you recommend for my particular circumstances? And different plants have different pH preferences as well. So you just want to make sure that you're not changing your pH in a way that doesn't favour the plants that you're trying to grow as well. And then the final question I had here was, what does living soil look like? That's a really good question. I think we know it when we see it, and I know that's not a particularly precise answer, but if you can take a handful of soil and it, you know, retains some structure, it's got lots of organic matter in it, it's, you know, a nice dark rich color, they're really good indicators of a soil that's really, I think, got lots of organic matter in it, and it's the organic matter that's going to feed the life in the soil. The other thing is, you know, in a happy, healthy soil, it doesn't take very long to find a couple of earthworms as well. So that's another good indicator. And then the final one I'd say is plants are really a product of the environment that they experience. And so if your soils are happy and healthy, then a nice living soil, you're going to have nice plant growth in there. If the plants are looking really sick and there's not much life or activity in your soil, then I think that should be fairly evident as well. That was the list of the questions that I had thus far. I don't know if any more had come through on the chat. Naomi?
Yes, Tim, we had one other question from Frank. What are your thoughts on soil pH?
Hi, Frank. I have lots of thoughts on soil pH. Look, it's interesting. If people say to me, what is the chemical parameter? If you could only know one chemical parameter about a soil, what would it be? I would always say pH, because pH is such an important thing for regulating the availability of different nutrients. So some nutrients are more available at neutral pHs, some at acidic pHs, some at alkaline pHs. So soil pH is a really important indicator of a whole host of other things as well. It's hard to say that there is an ideal pH for a soil, but I think there's an ideal range, and you want to be somewhere around that sort of neutral range. Either side is fine, but if you're getting too high or too low, then you might consider some sort of soil amendment. But yeah, pH is a fundamentally important thing. The other point about pH is, you know, soils have their pH and we can do things to try and change them, but we can also try and work within the range that we've got as well. And so that can also influence the kind of plant selections that you might make. And again, you know, if you're talking to a nurseryman and saying, you know, I've got a pH of 6.4 or, you know, 8.2 or whatever it may be, can you make some recommendations about what might grow, what kinds of amendments I might need to make? That's probably the best thing you can do to get specific advice about your particular circumstances. But yeah, no, that's a great question. Thank you, Frank.
That's all the questions on the chat. So unless you have anything else you'd like to plug, I think everyone has had the chance to ask their questions. I'd just like to say that was amazing, and who knew that only 0.1 millimetre of soil is gained every year? It's astounding. We really do need to look after our soil.
We do. Look, I couldn't sum it up better. So yeah, thank you for the opportunity, Naomi. I think this is a great program, and I'm really pleased to be part of it.
Thank you, and we'll see everyone else later. This will be posted on YouTube after if you want to rewatch and find anything out again.
Great, thank you.